Hello, this is Mr. Stansbury. I'm going to take you through the notes on solve linear quadratic systems. At the end of this, you should be able to say I can use different methods to solve and graph nonlinear systems, and I can describe solutions to nonlinear systems. Okay, so first things first. The graph to the right over here shows the linear quadratic system composed of a parabola, the blue line here, which has got this equation, and then the line, which is the red here. Okay, how many points of intersection does this system have? So hopefully you can look and see right here that it intersects right here at 1 point. Okay, now if we translate the red line f of x equals 2 up by 3 units, then how many intersections does the line system have now? So here it is, up 1, 2, 3 units. Now, hopefully you can tell that we've got 2 points of intersection, right? Right there and right there. So that would be 2 points. And then last part here is if we translate this line down by 4 units, so this original red line, we move it down by 4 units, how many points of intersections do we have now? Okay, so here's the original graph, went down 4 units. Hopefully you can tell now that it does not hit this blue line at all, so that's going to be 0 points or no points. Okay, so a general question, how many solutions are possible from a linear and a quadratic equation? 0, 1, or 2 points. Okay, so what we're going to do now is we're going to take the linear equation and a quadratic equation, and we're going to solve them. So what we're going to do first is we're going to solve them algebraically, and then we'll just take a quick peek at what the graph looks like so that we can verify everything. So we have these two equations here. To solve these, our best bet, like this second equation here, we got y equals 3x squared plus 24x plus 48, right? So what we want to do is we know that wherever we see a y, we can plug this in. So we're going to take all that stuff there and plug that in for this y. So we're going to take this equation down here, 2x minus y, we now know is 3x squared plus 24x plus 48. That's a 24. There we go. Not a 2y. 24x plus 48. And let's see. And then this all equals 9 over here because we're 2x minus, this is now y, equals 9. So now we're going to, let's first thing distribute this negative through to each piece. So we get 2x minus 3x squared plus 24x, minus 24x, because we did distributed the negative through. 24x minus 48 equals 9. And then our 2x and negative 24x can combine together to get negative 22x, and we still have the negative 3x squared and the minus 48 equals 9, and we're going to want to make one side equal to 0. So easiest way is to get rid of the 9 from here. So subtract 9 from both sides here, and we get negative 3x squared minus 22x minus 57 equals 0. Now, if you'll remember back to the quadratic, if you have it in this form, ax squared plus bx plus c equals 0, which is exactly the form we have it in, then we can plug it into the quadratic for each piece here, right? So if we're going to use that, let's do that right down here. X equals negative, you know what, let's do this first. Let's figure out what a, b, and c are. A is however many x squareds we have, negative 3. B is how many x's we have, negative 22. And then c is the number of constants we have here, and that's negative 57. Now, we could go through and actually multiply both sides by negative 1 here to get rid of all these negatives, but the negatives will work just fine too, so either or. Since we've written it down already, let's just stick with that. So we got x equals negative b, which is negative 22, plus or minus square root of negative 22 squared minus 4 times a, which is negative 3, times c, which is negative 57, all over 2 times a, which is negative 3. Okay, so simplifying this, we get x equals 22 plus or minus, and now we're going to need to probably get a calculator for that. Okay, so we put in our negative 22, make sure you put it in parentheses, squared, We know we should get a positive number out of there, and we do. Square root of 484. And then negative times a negative times a negative is negative. So let's see what 4 times 3 times 57 is. 4 times 3 times 57 gives us 684. All over negative 6. And when we simplify into the radical here, we get x equals 22 plus or minus, and we get square root of negative 200 over negative 6. Now, big key right here. Once we get a negative under the root, we can't do that. That's imaginary numbers. So as soon as we get that, that means we have no solutions. Okay? And the graph of this equation looks like this. So here's the graph of this quadratic. Here's the graph of this linear piece here. And as you can tell, they do not intersect at all. So square root of a negative instantly means we have no real solutions. Okay? Okay, we're going to do a couple more quick ones. But before we do that, we're going to do a quick little comedy break here. All right. Solve the system of equations algebraically. So same exact thing that we just did. We're going to go through and we're going to look. We've got y equals. So, oops, I keep doing that. Let's see. So we're going to take these here, this here, and we're going to plug it in for this y right there. Okay. Now, one quick thing, because you're probably not as a big fan of fractions like I am. Before we even do that, I'm just going to multiply everything on both sides of this equation by 2, and we'll get rid of our fractions just to make our life a little bit easier. So we got 2x equals negative 2 times half of negative 1/2 times 2 is negative 1y. And then 2 times 1/2 is plus 1. So now we'll take this here and plug it in for that negative y there. So we get 2x equals negative x squared minus 4x plus 2, and then the plus 1 there, right there. And we're going to distribute through and simplify. Okay, so we get 2x equals negative x squared. Negative times negative is positive 4x minus 2 plus 1. So negative x squared plus 4x, we get negative 2, and 1 gives us negative 1. And then we want to set this equal to 0. So let's subtract 2x from both sides here. And we get 0 equals negative x squared plus 2x minus 1. Okay, so we can use our quadratic because we're all in the right form here. So let's say a is going to be negative 1, b is going to be 2, and c is going to be negative 1. So we'll plug it all in here. X equals negative b, which is 2, plus or minus square root of b squared, which is 2, minus 4 times a, which is negative 1, times c, which is negative 1 also, all over 2 times a, which is negative 1. So we get x equals negative 2 plus or minus, and let's see in here, 2 squared is 4. And then negative times a negative times a negative is a negative. 4 times 1 is 4, all over negative 2. So we get x equals negative 2 plus or minus the square root of 0 over negative 2. Now, square root of 0 is just 0, so that pretty much just disappears. And we have negative 2 over 2, which just gives us 1. So we know that our x value is 1, and we only have one x value, so that means there's only going to be one solution. So to figure out what that solution is we want to take that 1 and plug it in for the x in either one of these. I'm going to plug it into this top one here, because then as soon as we simplify everything, it tells us exactly what y is. So let's try that. So we get y equals 1 squared minus 4 times 1 plus 2. So we get y equals 1 minus 4 plus 2. So y is going to equal negative 1. So our solution where they intersect is going to be x is 1, y is negative 1. So there's our solution. And here's the graph of both of them. There's our quadratic, there's our linear, and you can tell right there it hits there at magically at 1, negative 1. Okay, one more quick problem here and we will be done. Okay, so here we have this one here. We could plug either or, but I don't want to square this thing here, so we're going to take this and plug that straight into this y here. So we get x equals negative y, which is now x squared minus 4x plus 2 plus 6. So we get x equals negative x squared plus 4x minus 2 plus 6, which simplifies to negative x squared plus 4x plus 4, and then we want to subtract the x from both sides, right? And we get 0 equals negative x squared plus 3x plus 4. Okay, we can always plug this into the quadratic. You could factor this too, but we'll just keep plugging into the quadratic since we know that's always going to work. Okay, so we know that a here is going to be negative 1, b is going to be 3, c is going to be 4. So we get x equals negative 3 plus or minus the square root of 3 squared minus 4 times a, which is negative 1, times c, which is 4, all over 2 times negative 1. So we get x equals negative 3 plus or minus 9. Negative times a negative is positive, plus, so we got 4 times 1 times 4 is 16, all over negative 2. So we get x equals negative 3 plus or minus the square root of 25 over negative 2. And we know that this is going to be x equals negative 3. The square root of 25 is 5. So it's going to be negative 3 plus or minus 5 over negative 2. So we're going to want to do each one of those. So we're going to get x is going to equal negative 3 plus 5 over negative 2. And we're also going to get x equals negative 3 minus 5 over negative 2. So negative 3 plus 5 is 2. 2 divided by negative 2 is negative 1. Negative 3 and negative 5 is negative 8. Negative 8 divided by negative 2 is 4. So we end up getting two different x values. So that means we're going to have two different solutions. So let's figure out what each one of those is. Plug each one of these x's back in to see what the y is going to be. So we'll do x equals negative 1 first. Plug it into this here. Y equals negative 1 squared minus 4 times negative 1 plus 2. And we get 1 plus 4 plus 2. So our y is going to be 7. So that means one of the solutions is going to be at negative 1, 7. One of our solutions. And then we'll plug in x equals 4 to see what that gets us. We get y equals 4 squared minus 4 times 4 plus 2. So we get 16 minus 16 plus 2. So our y is going to be 2. So that means the other solution is going to be at 4 and 2. So here's the look at the two graphs here. You can tell there's this intersection there, and that's right at the two spots that we found. Here's negative 1, 7, and then here's 4 and 2 for our two solutions. Okay? All right, that's all we have for solving linear quadratic systems. If you have any further questions, please feel free to ask in class. Thanks.